Hi dear students, welcome to Geeta's classes. In this class we are going to do some problems on Laplace transforms from unit 3. It contains 3 parts. In the first part we will do some problems on Laplace transforms by various methods covering all the types. And second part will be on inverse Laplace transforms, and the third part will be on solving the differential equation by using Laplace transforms. So first part, before going to the first part, you have to be thorough with Laplace transforms for these formulas. All the formulas are available in the previous classes with the proofs. So these are all the theorems and formulas you have to be thorough with. Okay, then only we can do the problems. So we have Laplace transforms and inverse Laplace transforms are also there. So these are the functions and the theorems. So now we'll start doing problems. So first problem is state and prove linearity property of Laplace transform. So this is the statement: if a and b are constants and f and g are any two functions of t, then L of a into f of t plus b into plus or minus b into g of t is equal to a into, I can take this constant outside, a into L of f of t plus or minus b into L of g of t, or you can write L into f bar of s plus or minus b into g bar of s is also fine. So how to prove that? By definition, we know that, consider the LHS, and by definition it is e power integral 0 to infinity e power minus st into whatever we have in this you have to write. So a into f of t plus or minus b into g of t. We know by integration it is linear. I can take the constant outside and we can split them. Two functions f of t and g of t, I can split them. So I can write it as a into integral 0 to infinity e power minus st f of t plus or minus b into integral 0 to infinity e power minus st f of t dt. So that is equal to, by definition again, this is integral 0 to infinity e power minus st f of t is nothing but L of f of t, and integral 0 to infinity e power minus st g of t, this is g of t dt is equal to L of g of t. Okay. Yes. So next problem is find the Laplace transform of the function f of t. It will be given like this. So from 0 to 1 by 2 it is defined as t, and minus 1 by 2 to 1 it is defined as t minus 1. So how to prove that? How to find out the Laplace transform? L of f of t is equal to, by definition it is integral 0 to infinity e power minus st f of t dt. But the function is defined from 0 to 1 by 2 it is defined as t, and 1 by 2 to 1 it is defined as t minus 1, and here it is up to infinity it is defined as 0. So split the integral into 3, integral 0 to 1 by 2 e power minus st f of t dt, 1 by 2 to 1 e power minus st f of t dt, and 1 to infinity the same function. So integral 0 to 1 by 2 e power minus st into f of t is defined as t. In this interval it is defined as t, so I am replacing it by t, plus e power minus st into 1 by 2 to 1 it is defined as t minus 1. So write that function. And from 1 to infinity it is defined as 0. So this term will not be there because it is defined as 0. So now let us integrate. So integral 0 to 1 by 2 t into e power minus st dt plus integral 1 by 2 to 1 t minus 1 into e power minus st dt. Using Bernoulli's extended formula for integration by parts, we can write t into e power minus st by minus s. Integrate with respect to t. So minus s. And minus of, keep on differentiating the first bracket, keep on integrating the second bracket by Bernoulli's formula. So if you differentiate t, you will be getting 1, and minus st e power minus st by, already we have one minus s, one more minus s will come, so it will become s squared. In the same way, t minus 1 into e power minus st by minus s, and minus of differentiating this with respect to t, we will get 1 and e power minus st by s squared. Now we have to apply the limits. In the first one is 0 to 1 by 2 and second is 1 by 2 to 1. So if you apply the limits and simplify, you will be getting 1 by s squared minus 1 by s minus 1 by s into e power minus s by 2 and minus 1 by s squared into e power minus s. This is the answer. Next is L of find the Laplace transform of 5 sin t plus 2 sin 3t. So 5 into, by using linearity property, I can take this constant outside and separate these functions. So 5 I can take it outside into L of sin t plus 2 into L of sin 3t. 5 into what is L of sin t? 1 by s squared plus 1 plus 2 into what is L of sin 3t? Actually sin at is a by s squared plus a squared. So here a is 3, a value is 3, therefore 3 by s squared plus 9. That is equal to 5 by s squared plus 1 plus 2 into 3, 6 by s squared plus 9. Now, L of e power minus 3t into 2 cos 5t minus 3 sin 5t. So, I can apply this e power if any function is multiplied by e power at or e power minus at. Try to recollect that you have to apply first shifting theorem. So, by first shifting theorem, without this e power minus 3t, whatever function is there, you find the Laplace transform of that function and replace s by s plus 3 because you have e power minus at, s by s plus a. If it is e power at, s by s minus a. Okay, so replace s by s plus 3. So, now 2 into L of Laplace transform of cos 5t is s by s squared plus a squared. Here a is 5, so 25. Minus 3 into L of sin 5t is 5 by s squared plus 25 and in which you have to replace s by s plus 3. So 2s minus combining both the denominators are s squared plus 25. So combining 2s minus 15 by s squared plus 25 in which s is to be replaced by s plus 3. So wherever you have s, replace it by s plus 3. So 2 into s plus 3 minus 15 by in the place of s, again s plus 3 in the denominator also. So s plus 3 the whole squared plus 25. So if you simplify 2s plus 6 minus 15 by s squared plus s plus 3 the whole squared is s squared plus 9 plus 6s plus 25. Simplifying you will be getting 2s minus 9 by s squared plus 6s plus 34. Now find L of e power minus 3t into sin 5t sin 3t. If you have product like this, you have to write it as sum of the functions. Okay. Before that e power minus 3t, it is multiplied by e power minus 3t. So without this e power minus 3t, you find the Laplace transform and replace s by s plus 3 by using first shifting theorem. And we have we know that 2 sin a sin b is cos of a minus b minus cos of a plus b. Therefore, here a is equal to 5t, b is equal to 3t. So, cos of a minus b is 2t. So, cos 2t minus cos a plus b is cos 8t. So, cos 8t divided by 2 because 2 sin a sin b is this formula. So, 2 is not there. So, divided by 2. So, 1 by 2 into L of cos 2t again using for the linearity property, I can separate them. So 1 by 2 into L of cos 2t. Cos 2t is s by s squared plus 4. Cos 8t is s by s squared plus 64 in which s should be replaced by s plus 3. So 1 by 2 into s plus 3 by s plus 3 the whole squared plus 4 minus s plus 3 by s plus 3 the whole squared plus 64. Then next is find L of t into e power minus t into cos ht. So you have to be thorough with the formulas, then only all the theorems, then only we can apply in the problems. So without this t into e power minus st, you have to find the Laplace transform. So L of cos ht is s by s squared minus 1 squared. Okay, then multiplied by t. Always remember multiplication is you relate it with differentiation and division you relate it with integration. Okay. So if you multiply by t, it is by formula, it is minus d by ds by into s by s squared minus 1. And differentiate this denominator, it is u by v form. So denominator is s squared minus 1 the whole squared and numerator it is s squared minus v into du by dx ds. So it is 1 minus s into, differentiate this s squared minus 1 with respect to s, you will get 2s. So minus of s squared minus 1, simplifying this, you will be getting s squared plus 1 by s squared minus 1 the whole square. And now multiply, we have found out for t into cos hat, now multiply by e power minus at. So e power minus at or e power plus at means first shifting theorem. So without this function, find the Laplace transform and replace s by s plus 1. So without that, what is the Laplace transform? Already we have found out to be s squared plus 1 by s squared minus 1 the whole squared, and replace s by s plus 1. Okay. So replacing s by s plus 1 the whole squared plus 1 in the numerator, and s plus 1 the whole squared minus 1 the whole squared in the denominator. So simplifying, you will be getting s squared plus 2s plus 2 by s squared plus 2s the whole square. Next is also similar problem. So L of sine 3t you have to find out, then multiply by t, it is differentiation minus d by ds, and replace s by s plus 1 because it is multiplied by e power minus t. Okay. So next is define unit step function and find the Laplace transform of unit step function. Unit step function is defined as 1 and if you represent this geometrically, it is 0, and up to a it is defined as 0. In this interval it is defined as 0, and in this interval it is defined as 1. Okay. So if you want to draw the graph, up to a it is 1, it is 0, sorry, up to a this is 0. From 0 to a it is 0, and a to infinity it will be 1. If you define this as 1, so from a it is 1. So unit step function, this function is known as unit step function. Okay. So find the Laplace transform of unit step function means L of u of t minus a is integral 0 to infinity e power, by definition, e power minus st into u of t minus a. What is the definition? From 0 to a it is 0, and a to infinity it is defined as 1. So first term will not be there. So if you integrate, L of u of t minus a is integral a to infinity e power minus st into 1 into dt, therefore it is e power minus st dt. By integrating and substituting the limits, e power minus infinity minus e power minus as. E power minus infinity is 0, so simplifying you will be getting e power minus as by s. This is the Laplace transform of the unit step function. It is also known as Heaviside function, Heaviside unit step function. Next is a different problem. You have all the combinations here. So innermost, find out, you replace all these things without t, without integral, without e power minus t, and divided by t. So you find out the innermost, it is integral L of sine t. Okay. So L of sine t is 1 by s squared plus 1. If it is divided by t, integral s to infinity, always I told you multiplication of t is, you try to relate it with differentiation, and the division of t with the integration. Okay. So if L of sine t by t it is division, therefore integral s to infinity 1 by s squared plus 1 ds. That is tan inverse of s from s to infinity. That is, if you apply the limits, tan inverse of infinity minus tan inverse of s, that is pi by 2 minus tan inverse of s, that I can write it as cot inverse of s. So if it is multiplied by, now innermost sin t we have found out, then sin t by t, then multiply by e power minus t. So L of e power minus t into sin t by t is cot inverse of s. Already we have found out sin t by t, L of sin t by t as cot inverse of s, in which s is to be replaced by s plus 1. So it is cot inverse of s plus 1. Okay. Now integral. If it is integral, then divide it by s. So 1 by s into L of, without this integral, whatever you have found out the Laplace transform of that function, and divide it by s. So 1 by s into cot inverse of s plus 1. Now again multiply with t. Okay. So multiplication with this t means without t you have to find the Laplace transform. That is, already we have found out to be 1 by s into cot inverse of s plus 1. So divide it by minus d by ds of, if it is to be multiplied by t, minus d by ds of this function. So integrating and simplifying, you will be getting minus s into, that is u by v form. So in the denominator it is s squared, okay, and s into minus 1 by differentiate cot inverse of s plus 1 with respect to s. So minus 1 by 1 plus s plus 1 the whole square, minus of s is 1 into cot inverse of s plus 1 into differentiation of s is 1. And simplifying this minus and minus, it will become plus, and minus of. So again this will also be plus. 1 second, let me check. So this will also be minus of, so this will become plus. Okay, s plus s squared plus 2s, and now you take the LCM. So L squared plus 2s plus 1 plus 2 will come down, and minus of s. So plus, you take this as LCM. So s squared plus 2s plus 2 into cot inverse of s plus 1 divided by s squared into s squared. This the LCM will come down. S squared plus 2s plus 2 will come down. Okay. So this is the answer. Next is L of e power minus t into integral 0 to t sin t by t. So L of sin t is 1 by s squared plus 1 by divided by t means integral s to infinity. It is similar to the previous problem, and integral 0 to t sin t is 1 by s into cot inverse of s. Now you have to multiply with e power minus st. So without e power minus st, we have found out that inverse Laplace transform, and it should be multiplied by 1 by s, or that is divided by s. Okay. And in which s should be replaced by s plus 1. E power minus t is to be multiplied means again first shifting theorem. So replace s by s plus 1. So this is the answer. Next is evaluate integral 0 to infinity cos 6t minus cos 4t by t into dt. Whenever you have evaluation from integral 0 to infinity, we know that L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. Okay. So let us find out this f of t. L of f of t you have to find out. Then compare with integral 0 to infinity e power minus st f of t dt. So we have the integrand is cos 6t minus cos 4t by t. So let us find out the Laplace transform of this function. Then let us compare with integral 0 to infinity. Okay, so without this 0 to infinity, whatever is available, find the Laplace transform of this function, that integrand, and compare with integral 0 to infinity. That is defined in the left hand side, and compare. Okay, so cos 6t minus cos 4t, we know that Laplace transform of this is s by s squared plus 36 minus s by s squared plus 16. Okay, so we have found out to be this. Whenever you have like this in log of something s squared, so again it will become infinity, right? If you substitute, it will become infinity. So always try to take s squared. You try to write it as, this is log of 1. Try to write it as s squared. You take it outside, s squared outside, and always try to write it in the denominator. S squared should come in the denominator, so that it will become 0 when you substitute infinity. So s squared I am taking it outside. This is not infinity, it is 1. Log of 1. Okay. Log of 1 plus 0. Actually this will become log of 1 plus 0 and divided by 1 plus 0. Therefore it will become log of 1 only. Log 1, which is 0. Okay. And again you take the LCM, s squared plus 36 minus you will be getting, therefore the denominator will come to the numerator and numerator will come to the denominator. Okay. Now divided by t we have found out this to be, and by definition of the Laplace transform in the left hand side, by definition it is integral 0 to infinity e power minus st cos 6t, this is equal to 1 by 2 into, if we have e power minus st, we have this one, and put s is equal to 0, this will become 1. We want to evaluate integral 0 to infinity, only this function, right? This is to be evaluated. So if you substitute 0 in the place of s, this will become 1. So we can get the required integral. Okay, so integral 0 to infinity cos 6t minus cos 4t by t dt is equal to 1 by 2 into, substitute s is equal to 0. So this will become log of 16 by 36. And 1 by 2 means power, you can bring it to the power, that is root of 1, power 1 by 2 means root of, right? So if you take the square root, you will be getting 4 by 6, log of 4 by 6. 4 by 6 it is, if you simplify, it is 2 by, if you cancel, this is 2 by 3, log of 2 by 3. Okay, that is the answer. Similarly, evaluating means you have to compare with. So e power minus 2t already we have. So without that you find the Laplace transform, so that we can compare with e power minus st. Okay. So we know that L of sin 3t is 3 by s squared plus 9. T into means differentiate, minus d by ds of L of sin 3t. So 6s by s squared plus 9 the whole square. So we have L of t into sin 3t is 6s by. Whenever you have evaluation, evaluate the integral from 0 to infinity, compare it with the definition. L of e power minus st into, see, by definition of Laplace transform, this is the definition. And here we want to evaluate e power minus 2t. So substitute s is equal to 2. In the place of s, if you substitute 2, you will get the required integral. If you simplify, you will be getting 12 by 169. Okay. So next is prove that e power, again integral 0, it is equivalent to evaluation only. Okay. And here we have given, they have given the answer also, log of b by a. You are asked to prove that this is equal to. So without e power minus st, you find out the Laplace transform. Here e power minus at minus e power minus bt by t. So let us find out the Laplace transform of this function. So as we have to proceed as we have done in the previous problem. So this is again log 1, 0. So divided by, see, by definition, this is log of, Laplace transform of e power minus at minus log e power minus bt by t is equal to log of s plus b by s plus a. I want to evaluate integral 0 to infinity. So by definition in the LHS is integral 0 to infinity e power minus st into the sum function, that is equal to log of s plus b by. But we want only this integral of this function only we want. So substitute s is equal to 0, we will get the required function. And the right hand side also puts s is equal to 0, we will get log of b by e. This is what we have to prove. Next is again similar problem. You can go through this. So L of sin squared t by t you have to find out and substitute. Here we want e power minus t into, therefore put s is equal to 1. Okay. And in the right hand side also, if you substitute s equal to 1, you will get the required answer. Next is find the Laplace transform of the periodic function with period 2a. That is 0 to a it is defined as t, and a to 2a it is defined as 2a, 2a minus t. The periodic function means here a and 2a and 3a, 4a. That is whatever function is defined, here it is defined as t and 2a minus t. And it is the repeated function, okay, 2a minus t. The same function is repeated from 2a to 3a. This is a periodic function of period 2a. That means from 0 to a it is t, and a to 2a 2a minus 3. So the same function will be repeated from 2a to 4a and 4a to 6a and so on. Okay. That is why we can write L of f of t. If it is a periodic function of period 2a, then 1 by 1 minus e power minus the period into s and integral 0 to the period into e power minus st f of t dt. So from 0 to a it is defined as t, and a to 2a it is defined as 2a minus t. Okay. So by integrating t again using the formula, Bernoulli's formula by extended extended integration. Extended formula for integration by parts. that is t into e power minus st by minus s, and minus of, keep on differentiating the first bracket, keep on integrating the second bracket. Against the second function, in the place of t we have t minus 1. So t minus 1 into, and differentiating this 1 into e power minus st by s squared. And substituting the values, the limits, upper limit minus lower limit, we will get the function as 1 by s squared into 1 minus e power minus 2as into, all the other terms will get cancelled, and 1 minus 2 into e power minus as plus e power minus 2as. So 1 minus 2 e power minus as and e power minus 2as. This can be written as 1 plus e power minus as the whole square. That is a plus b the whole squared form. If you expand it, you will be getting this. Okay. And in the denominator also we have 1 minus of e power minus 2as, that I can write it as e power minus as the whole square. That is e power minus as the whole square is e power a power m the whole power n is a power m into n. Okay. So 2 you can multiply. So you will get the same function. That is e power minus 2as you will be getting. So here it is 1 plus, here it is not plus, it is minus. 1 minus e power minus as the whole square, because 1 minus 2. A squared plus b squared minus 2ab. Okay. So this is minus. So 1 minus of e power minus as the whole square, and the denominator it is a squared minus b squared form. A squared minus b squared means a minus b into a plus b. So I am writing it as 1 minus e power minus as and 1 plus. So one term in the numerator and this term will get cancelled. So you will be getting 1 minus e power as by a squared plus 1 plus e power minus as. Actually, if you are not asked to prove, you can stop in this step itself. Okay, you need not do all the simplification. Here itself you can stop. Or if it is asked for proving this, then you have to proceed like this. And again we can simplify. We got that 1 minus e power minus as by 1 plus e power minus as. So I can take e power minus as by 2 outside. I can write it as e power as by 2 minus e power. Actually, if you write this, if you want to take this outside, you take half of that. So that I can write it as. So if you you can verify e power as by 2 into e power minus as by 2 into e power as by 2 is what? E power 1. It is 1, right? E power minus as plus 2 plus e power as plus 2. Those two will get cancelled. You will be getting e power 0, that is 1. That is what is 1. Okay. And if you multiply this, you will be getting e power minus as. So you can simplify. Whenever you are taking it outside, check whether you are doing correctly or not. Okay. So in the denominator again, I am taking e power minus as by 2 outside. So you can write this as e power as by 2 minus e power minus as by 2, and in the denominator you will be getting plus. So this can be written as sin h as by 2 divided by 2, and in the denominator also cos h as by 2 divided by 2. That divided by 2 will get cancelled. So you will be getting in the numerator it is sin h as by 2, and the denominator cos h as by 2. It will become tan h as by 2. Okay. Similarly, in the same way, you will have this function. Actually, these problems are important problems. Sometimes you will be asked to prove that L of f of t is equal to 1 by s squared into tan h as by 2. In the same way, 1 and minus 1. Okay, 0 to a by 2 it is defined as 1, and in the a by 2 to a it is defined as minus 1. It is exactly similar to the previous problem. I have done the steps also. You can go through this. So here again you can stop this function like this. Okay. If it is asked for proving, again you have to take e power minus as by 4 outside and simplify. You will be getting tan h as by 4 also. Okay. So hope it will be useful for you. Please give a like and share it with your friends so that it will be useful for them also. And in the next class I am going to explain inverse Laplace transform, that is part 2. And thank you so much for listening.